Good afternoon, Cloud fans, and welcome back to Google Cloud Next. We're here in Las Vegas, Nevada. My name is Savannah Peterson, joined for all the insights with the intimidable is the word I was going for, Dave Vellante.
What?
Yes. I mean, I'm just saying you're one of a kind.
Thank you.
That's all I'm saying.
Kind of you.
It is. It is. And you know, actually.
More inside baseball here, but sorry.
It's been a lot. It's been a lot. Tune into all the segments and you might understand our jokes. Otherwise, sorry for leaving you hanging in the beginning. No, but actually, another one-of-a-kind situation and conversation that we're about to have is with our next guest, Mohamed. Welcome to the show. Thank you so much for coming.
Hey, Savannah. Hey, Dave. Thank you for having me.
It's an absolute pleasure. I am so excited to hear more about what you're doing at Staque to connect cutting-edge science and technology. So tell us about Staque, the mission, a little bit about your story.
Yeah, I mean, you nailed it pretty much. You know, we exist to bridge the gap between cutting-edge science and industry implementation, particularly cutting-edge computer science. You know, so my background was academic researcher, professor before I became an entrepreneur about 9-10 years ago. And having lived in both worlds, I saw a huge disconnect where the cutting-edge advances we do in science and research take decades to make their way into industry, you know, and in some cases even longer than that. So our whole mission is to cut down that time to months, you know, or weeks, if possible, you know, to solve industry's most complex problems. In a nutshell, we're a high-performance computing company. You know, this is how I would describe ourselves. And within HPC, we focus on two main areas. One is building agents for solving complex problems, and the other is commercializing and productizing quantum computing. So yeah, that's a little bit about us.
Such an important mission. You think about it.
Yeah.
You think about I mean, I'm obviously US biased, but you think about the great research centers in the United States over the years. Xerox PARC. I don't even know what happened to Xerox PARC.
It's actually a great question.
Bell Labs, now owned by Nokia. I mean, when AT&T broke up, Bell Labs basically dissipated. IBM still has legit research.
Yes, they
but
do.
for years, they couldn't translate their research into commercial products.
Yep.
They struggled for decades. Now that seems to be, you know, getting better and more pragmatic. But so you are really filling a need. Obviously not as big as those other ones that I mentioned, but congratulations on the vision and actually putting it into action. It's very exciting. Because I was going to ask you why you started the company, but it's clear why.
Well, and I think building on that, something that stuck with me is, you know, you could say this just even walking around the show floor. A lot of companies try and be everything to everyone. And it's not necessarily the strongest marketing strategy, nor does it necessarily lead you to be front of mind or best in breed in one specific thing. I love that you were mentioning before we went live that your sweet spot is very specific niche problems.
Yep.
So I'm curious about your process as a leader and how you and the team identify which complex problem to go after now and next in the future.
Yeah, I mean, I'll go back to Dave's comment about AT&T Bell Labs, which has been a kind of an inspiration for us. You know, we kind of modeled our R&D process on the Bell Labs. But where we are different from our predecessors is that we work our way backwards from commercialization. You know, we look at the business value that we can create and then work our way backwards towards R&D rather than the other way around. So we don't build a tool looking for a solution, we look at a problem and then build the tool that fits that problem. And that's why, to your point, Savannah, focusing on niche use cases is really important. Because if you build general products or general solutions, they're just not going to fit with the pain points that the industry has.
Right.
So there are a couple of pain points that we have gone after quite heavily. One of which is modeling complex systems, you know, and using high performance computing to solve decision problems in supply chains, in manufacturing, in aviation. But ultimately the goal is that you have some optimization problem. You have a complex network, you have complex decisions to be made, you model it and then you solve it. And for that we have built an agent, which is a supercomputing agent which we call Super, you know. Cheesy name, I know, but you know, it's what we came up with. And Super is deployed actually. Super is deployed in commercial applications. There are other scientific computing companies that are using it to serve their clients. And then there are consumers directly using it as well. And the key use cases for Super right now have been in autonomy. Autonomous machines, planning their operations at scale, routing problems in supply chain, and last mile delivery. So that has been the focus for us.
I wonder if I could pick up on the supply chain one. So there are companies that are legacy collections of supply chain companies trying to solve this problem. And by infusing AI, building knowledge graphs. I mean, I think of a company like Blue Yonder, which is a collection of Manugistics and J2E, and all these kind of legacy companies. And they're doing some great work. But it's like my security question. I feel like supply chain is a do-over. And you're coming at it from a blank piece of paper. So I wonder if you could help us understand the efficacy of a new approach like yours compared to trying to fix. The advantage of the legacy systems is they have access to all this data, which is important. I'm curious as to how do you address that problem, but architecturally how you're thinking about it differently.
Yeah, that's a great question, actually. And the biggest issue whenever you go to a legacy industry and try to pitch a new solution is that there is status quo, right? And they want to see something tangible before they agree to utilize your solution. But it is really hard to show something tangible because you don't have access to data, you don't have access to their systems. So this is where we have seen a big advantage in using DataStax's tooling, to quickly spin up MVPs or even in some cases fully productized applications that we can show to end customers and say that this is how it's going to be. This is where you are right now, and once you work with us, this is how our AI agent is going to help you navigate complexity and solve it faster and save millions of dollars potentially. So once they see it in flesh, that's that aha moment where they say, okay, now we can have a conversation, now we can get into productization. So I think for us it is critical to demonstrate and demonstrate fast, and this is where some of the toolings we use has been a great enabler for us.
So data stacks, Langflow, that enables you to achieve real-time results, right? Can you explain that in a little bit more detail?
It's an interesting story, So we started building agents a while ago, but our COO, Krishna Ganesh, he had to do some demos really quickly, and it was a big customer. So he was like, okay, how do I do it? So he discovered DataStax, and he discovered Langflow as the platform, and he used it. And tomorrow there's a demo, and he's spinning it up. And it worked.
I love a COO that's a techie.
Yeah.
Yeah, I mean, he's very hands-on.
He's out there making MVPs.
Yeah, exactly. He's very hands-on with that stuff, And once he did, we looked at it as an organization and we said, okay, this is interesting. We should expand the usage of Langflow in our prototyping. And then we realized that we can actually take it from prototype to MVP to full product, which I didn't expect. I thought it was more of a prototyping tool, but that it has full production grade capabilities. So then we started moving our agents and building new agents on Langflow. And then that led us to discover AstraDB, because we were using vector databases. And with AstraDB now we have all of our AI flows sitting in one environment and seamlessly communicating with each other. But the key driver is speed at which you can spin up these AI agents using this tooling.
That's a big deal. Speaking of speed, you brought up Super, but and also Quantum, but haven't quite combined them together yet for us. You're our first, well, probably our real first quantum expert on the show this event. Right. So I'm curious, talk to me about how that enhances your ability to solve problems and how the hybrid compute future will help you navigate these really complex niche problems quickly and with extreme velocity.
Yeah, that's a great question. So Super is a supercomputing platform. It is not just quantum computing. It is classical high performance computing as well as quantum computing. The way it works is you define a problem in natural language. You upload a case paper, a presentation, or define it. Just a business executive has a crack at it. Defines the problem. Then it asks you clarifying questions and builds your problem statement. So that's where the AI comes in, the agent comes in. Once the problem statement is well defined, then it figures out how to solve it. And what is the key factor you're looking for? Are you looking for a superior solution? Are you wanting to cut down costs? Or do you need an answer really fast? So every morning when your supply chain is initiated or your drivers are going out to deliver, you want to optimize their schedules and adjust in real time in 2 minutes, get an answer. What is the key objective for you? And then accordingly it comes up with an architecture for the problem to be solved using a combination of classical and quantum computing. Where quantum computing comes in heavily is when you need answers fast. That's where you can cut down times from hours to minutes and in some cases seconds.
And sometimes even days, depending on how much you're...
It's true, yeah. So, totally. So I'll give you an example. In Canada there is a food group, Pattison Food Group. They're a grocery chain. They run quantum computing every morning to optimize their last mile deliveries. And it's a use case that we have been adjacent to, we have been close to through D-Wave and our partnership with D-Wave. But yeah, so those are the kind of use cases where quantum computing really shines. And the other one is where you need a high quality solution and the classical methods are just not getting you there.
Yeah.
For example, drug discovery. Or for example, building a new class of materials for a problem. So those are the problems where we see the most advantage from quantum.
I love that the grocery store is adopting quantum. On the front nose of quantum is the grocery industry. I mean, it makes sense. We had that conversation with Ian at MWC, which also makes sense. But it's quite fun to hear, honestly. It's very interesting. I got to ask you, since we're having this conversation, it's been a very spirited and healthy debate here on the desk about when Y2Q is coming. And when do you think we'll be at or maybe you'll say we're already there, a tipping point with quantum computing and its adoption at scale across the world, or at least across industries here?
So one thing we have to understand is that there are different models of quantum computing. There is the gate-based model, and then there is the quantum annealing.
Which is D-Wave.
Exactly, yeah. So think of the gate-based model as the solve-it-all model. But it is at a smaller scale right now. We have a few hundred qubits, in some cases, tens of qubits. And they're just not enough to model the complexity that's in the world, So gate-based is going to take a little while to get there. But on the annealing side, we have made more progress. We have reached a scale of 5,000 qubits. And that's the infrastructure we use heavily. We use both. We use gate-based as well. But when it comes to commercialization, we have seen more bang for our buck from quantum annealing at this stage. And quantum annealing is practical today. It is deployed today. I was at Qubits a week ago, actually, and I presented a live product, which is powered by quantum computing, and customers are using it today.
Well, I had Alan Baratz on at the New York Stock Exchange,
Yeah.
who's CEO of D-Wave, and I got an education on annealing, and they've been shipping their cloud-based service for quite some time, and they've now delivered an on-prem quantum computer, so they're actually in production.
It's happening.
So well, it's funny, because Jensen, of course, created a lot of controversy when he said it's a decade away. He sort of walked that back, and then at GTC they had Quantum Day. Again, I wasn't there, but I don't know, did you get any visibility on Quantum Day?
Unfortunately, I didn't. I did get to talk to a couple of our community members about HPC in that moment and about quantum, but I did not get to immerse myself in the 2-hour, 17-person panel that they had going on, quite literally 17.
But my takeaway is this is a journey for sure, right? And you're going to see different techniques, and it is going to evolve, probably over a decade. But the potential is enormous, especially when you start thinking, this is what I learned from Alan, the biggest blocker to AI is energy, right? Quantum doesn't have that problem, They've got other problems.
It does. But you're right, when it comes to sustainability of AI, quantum computing is going to play an important role, and that's the space where our core R&D is based. How do we intersect AI and quantum computing? And this is where, once again, our interaction and our relationship with DataStax is very important for us. Because DataStax is also an R&D driven company. It's not just about the tool, it's about the research that goes into the tool, and then how do you quickly put it in the hands of users. So when it comes to creating optimized fine-tuning and large language model training pipelines, I think our collaboration with DataStax is going to be a great catalyst for that as well.
What are some of the biggest challenges you have as you bring, for most people, I mean, it is bleeding edge technology, bring the frontline technology into some of these industries that are not historically necessarily known as the #1 early adopters of said new technology. What is that conversation like?
Yeah, it usually starts from something tangible. So our starting point with them is usually generative AI. That's how we start the conversation and show them the use cases of generative AI in their business. And then based on what problems they have and the complexity of the problem, we bring in technology, other technologies into it, like quantum computing. Like, we don't throw quantum computing at every problem, and the starting point is always, what's the pain point that we're looking to solve. I'll give you one more example of a key use case that we have delivered. There is a hormonal health company, Science and Humans, that we work with. They have been serving consumers, diagnosing and treating hormonal health conditions for several years. In the last couple of years, they have had explosive growth in usage. And they were getting to a point where their human clinicians just couldn't keep up with the demand. So what is the solution? You create AI clinicians. But that is a very sensitive topic, and a very sensitive application.
Oh yeah.
Because it's life and death, and
yeah.
Exactly, and all kinds of regulations.
It's an emotional space to be operating
exactly,
in.
Exactly.
Yeah.
So we work with them, and we designed our queues. We call them queues. Q is an AI agent product that we have. So we designed Q clinicians for them that specialize in certain health conditions, like thyroid or menopause or erectile dysfunction, so on and so forth. And now we're moving to a point where we need these clinicians to work together to account for the overall health, because your thyroids are not independent of your other hormones, right? I mean, they're interconnected. The whole body is a complex system. Now that's where we're bringing in quantum computing. You see, our starting point was AI agents, but then as AI agents need to scale, you need quantum computing or high performance computing to enable that. This is typically our journey, with our customers. Start with something very concrete, do an MVP, grow it to a product, and then bring in advanced technologies as needed.
Yeah, take them down that journey. I love it. All right, I've got one more question for you, Mohamed, and I'm actually really excited to hear what your answer is. So when we have you back on the show at Google Cloud Next 2026, what do you hope to be able to say then that you can't yet say today?
Yeah, I'm hoping a lot, actually. So
I'm excited, and tell us all the things you're hoping.
Yeah, so where I would like to be and what I would like to say is that leveraging quantum computing and high performance computing, we have been able to bring down the time to train large language models or fine-tune large language models by at least 20%. That is the goal. That is the quantifiable, tangible goal that we have defined for ourselves over the next 12 months. And actually, I'm trying to get data stacks fully aligned on that as well, and getting into it together and going after that goal.
I love that. That's one of the things that's really magical about this time period is there's so many companies and great minds collaborating across industries, across sectors, across teams. We look forward to hearing your update on that 20%.
Looking forward to be back as well.
Where are you at as a company in terms of capital raised? What can you share with us?
Yeah, so we have been profitable. We have been around for about 3.5 years. We're based in Canada, US, and UAE, particularly Dubai. Have been profitable since the inception because of our commercial focus. But now we are raising a round to accelerate some of the technological solutions and R&D that we're doing. So it's a $3 million round, and we have already $1 million committed. I hope, I don't know, my CFO is going to kill me for that or not, but I'm sharing some information here. I hope it's going to be okay.
So you guys funded it largely through positive cash flow.
Exactly.
Early on. Oh, congratulations. Love it.
Yeah.
So you pretty much still own the whole thing. Most of it.
Well, yeah.
Anyway.
No comments.
No comments.
Yeah, I was going to say, I was like, and that's about where we wrap this up. It is that time.
Well, just because it gives you flexibility, that's all I'm saying.
Sure.
No,
sure.
I mean, it gives you autonomy. You're not answering to a big, beefy board. And
you need capital
still
scale.
Still have some pride in your teamwork. Anyway, I'm here for that. Congratulations on everything. Really exciting stuff that you're doing, you and the team. And I genuinely cannot wait. You operate in the space that I cover here for theCUBE, so I genuinely cannot wait to see what comes next. Make sure you keep us posted, and we look forward to the next time you're on the show with us.
Appreciate Savannah, Dave. Pleasure.
Thank you, Mohamed.
Yeah.
you.
And thank you, Dave. This was a fun one. Nice to end on a little quantum note. I'm feeling I got a little spring in my step here at the end of day 2. I hope you all enjoyed that as much as we did. We're here in Las Vegas, Nevada at Google Cloud Next. My name is Savannah Peterson. You're watching theCUBE, the leading source for enterprise tech news.